Good day and Assalamualaikum. MCT Hafsa is Sulaiman, and today my topic is all about Theorem 4.16 to Corollary 4.18. In this discussion, focusing on the silk group, generators, and subset, the rules of the greatest common divisor, and indetermine the order of the subset. And now let us first discuss the Theorem 4.16. The theorem states that if G is a set group generated by A and B equals A raised to S, then B generated A subset H. The number of elements of subset H is equal to N divided by D, where D is the greatest common divisor of N and S. The theory also states that two generated subsets are equal if and only if their GCD values when n are equal. Now, let us discuss the proof. We begin when b equals a raised to s, then we let b raised to m equal the identity elements e. Substitute the b equals a raised to s. Now we get a raised to s quality raised to m equal e. Since G has order n, we also know that a raised to n equals e. Therefore, n divides m times s. Now let's D equal the GCD of n and s. Using the identity, there exists integer u and v such that d equals u and n plus vc. Dividing by d gives 1 equals u times n over d plus v times s over d. This means that n over d and s over d are relatively prime. The goal of this is to find the smallest positive integer m such that ms over n is an integer. Since n over d and s over d are relatively prime, n over d must divide m. Positive value of m is n over d. Here's the subset H contain n over d elements. Now let's apply the theorem. Consider integer sub-elements generated by 1. Since GCD of 3 and 12 equal 3, the subset generated by 3 contains 4 elements. Thus, the subset containing by 3 is 0. Then 3, 6, and 9, 0, 3, 6, and 9. For the second example, GCD of 8 and 12 equals 4. Therefore, the subset generated by 8 contains 3 elements, namely 0, 4, and 8. Next, the GCD of 5 and 12 equals 1, meaning 5 generated the whole group integer subset 12. Lastly, GCD of 9 and 12 equals GCD of 3 and 12. Since the GCD values are equal, the subset generated by 9 is equal to subset generated by 3. So let's moving on to Corollary 4.18. State that if G is generated by A and has order n, then the another generated of G are the elements A raised to R, where G and GCD of R and n equals 1. This means that exponent must be relatively prime to n. For example, in integer sub 12, the generators are 1, 5, 7, and 11 because all of them have a GCD equals to 1 when 12. To conclude, the theorem 4.16 helps us to determine the order of the subset generated by the elements in a set group, and the theorem also explains when two generated subsets are equal. The example of 4.17 showed the application in the subset 12, while the culinary 4.18 identify all the generators of the GNC group, set group. So that's all. Thank you for watching.